Welcome back to Aurora Tech Channel. Today, I will test the FlashForge AD5X, a multi-filament Core XY machine. At first glance, it looks like a mix of the BambuLab P1P and the A1 style AMS Lite. This machine hangs 4 spools on the right side and places the AMS in a separate box mounted above them. It combines the advantages of a Core XY with the simplicity of the BambuLab AMS Lite. It's priced lower than the BambuLab P1P machine without an AMS and also cheaper than other bedslinger multiple color combos like the A1 or the Creality High. It's only slightly more expensive than a single AMS unit. You can get it for as low as $359 depending on timing. It is probably the cheapest Core XY multi-filament printer on the market right now. Let's take a quick look at the specs. As a Core XY, it uses linear rods for the X and Y axes. The Z axis is supported by 3 lead screws and 4 linear rods. Print volume is 220 by 220 by 220 millimeters, slightly smaller than the regular size machines from BambuLab and Creality. The machine is compact. Table space required is about 18 by 21 inches, 450 by 530 millimeters, including room for the spools. The printer body itself is about 18 inches tall, but you should add another 7 inches for the Bowden tubes. The AD5X's specs are similar to the entry-level 5M, except it uses a new print head that supports multi-filament printing. The supplied nozzle is wear-resistant and can reach up to 300 degrees Celsius. The bed can get up to 110 degrees Celsius and comes with a double-sided PEI spring steel sheet. The nozzle is a quick swap design. It is not quite as fast to swap as the 5M or 5M Pro, but it is still easier than many so-called quick swap nozzles. FlashForge does not list the firmware, and I did not see any signs it is not Clipper. For slicing, FlashForge provides profiles in native Orca Slicer, although some features may be missing. They also released a skinned Orca Slicer for this machine, but I will test out both slicers. For network printing, it supports cloud printing, but you can also use local Wi-Fi, Ethernet, or print offline from a USB drive. It doesn't come with a camera or enclosure. You have to purchase them separately as optional upgrades. But considering the price point, a Core XY printer with an all-in-one multi-filament system still offers pretty good value. I would like to thank FlashForge for sending this machine and for sponsoring today's video. Even though this is a sponsored review, we will stay unbiased and point out any cons of the machine. With that said, let's get started. The box for this printer is smaller than those of other standard size Core XY machines. The unit is protected by foam and placed inside a bag that makes it easy to lift. All the accessories are packed inside the machine to save space. In addition to the printer, the box contains 4 spool holders, a multi-filament box with a mount, some tools, Bowden tubes, cables, and a small amount of test filament. Most parts of the machine are pre-assembled. We only need to snap on a few components. First, the touchscreen is secured by a metal bracket. Just remove it and snap the screen onto the frame. The metal bracket is thick and good quality, but it is not needed afterward. Next, attach the mount for the multi-filament box to the right side of the printer. Connect the Bowden tubes from the box to the print head and attach the cable that runs with the Bowden tube. Then flip the machine and connect the remaining cable from the box to the printer. Mount the 4 spring-loaded spool holders on the right side. They are not identical, so follow the labels. Otherwise, the spring-loaded rewinding mechanism will not work. Finally, remove the screws at the bottom that were used to secure the bed, then connect power and turn the machine on. Select the language, then remove all protective materials. We already did this. Select your Wi-Fi network. It supports both 2.4 GHz and 5 GHz bands. After entering your Wi-Fi password, an IP address will appear. If you want to use the cloud service, download the app and register an account. I will skip that and use local Wi-Fi. The printer will then perform bed leveling and input shaper calibration. The whole process takes about 10 minutes. After that, load the filaments. As the spools are similar to those on the A1, they fit most but not all filaments. I tried some of the brands I have. In addition to the manufacturer's filaments, they accept VOXELPLA, Creality spools, and Chitu spools, and they also accommodate Prusa spools with smaller center holes that did not fit on the A1 or the Snapmaker U1. However, they do not fit spools with larger center holes, such as some older Sunlu spools. You must enter the filament type and color for each spool via the touchscreen. The available filament type options are limited. You may not find choices for nylon carbon fiber or polycarbonate. I will try printing nylon CF later in this video and show you how. After selecting all 4 spools, the printer automatically starts a 2-color test print of a poker chip size model. Because the print includes only 1 color change, it finishes in about 15 minutes. The completion dialog is too crowded with text and hard to read, and the OK and Continue buttons are confusing. I recommend moving the OK button to the right and relabeling Continue as Reprint on the left to match common UI conventions. Aside from that, everything seems to be working fine, and we can start the real tests. Let's go to the slicer to slice our first color print. If you want to use the native Orca slicer, it has a profile for the 5X and other FlashForge printers. I tried its network feature. It allows you to upload files, but because the printer does not use a standard web UI like Mainsail or Fluid, you cannot manage the printer from a browser or the Device tab. When printing multiple colors, it also does not have the option to enable the multi-filament box. This causes a filament runout message because the box won't feed filament to the extruder. You can still start the print manually from the printer's screen, but that's not ideal. For now, I have to use their skinned Orca slicer, which comes preloaded with profiles for common filaments. You can print directly from that slicer. It will enable the multi-filament box and let you choose the actual filament you loaded to match or substitute the color you select in the slicer. After upload, you can use the Device tab to manage the printer. By default, the printer does not include a camera. You must order it separately. The printer is not as fast as ultra-high-speed models, but it is in line with other recent generation printers. I let it print a few layers and checked the noise level. The sound meter was placed about 3 feet away. The noise level remained in the low 50s, which is quite quiet for an open-frame printer. I also timed the color changes. The first change, from yellow to black, light to dark, was timed from when the current color stopped printing to when the next color started. It took 1 minute 23 seconds, about 10 to 15 seconds faster than other AMS setups. Next was black to white, a dark to light change that normally requires more flushing and takes longer. This one took 2 minutes 20 seconds, also slightly faster than other fully enclosed AMS style setups. The final change, from white to purple, since it's also a light to dark color change, so it should be faster like the first yellow to black. It took 1 minute 26 seconds, which is in line with the first light color change. The print finished in 54 minutes. Since it only had 3 color changes, this multicolor print was not too slow. Filament waste was acceptable, the benchy weighed about 11 grams, the prime tower 3 grams, and the filament poops about 2 grams. The surface quality was decent. On the section printed with the silk purple PLA, the ringing was slightly more noticeable than with other colors. Cooling at the front was fine, even though the printer lacks an auxiliary fan. The top layers appeared normal with no under extrusion. We will move on to more color test prints. I will then expanding my Hello Kitty army. This is a relatively simple model, so on other printers, like the Creality Higher K2 series, I usually start with a 1.3 times flush. With this printer, I began with just 1 time flush. The reason is the distance from the nozzle to the top of the heat break is about 30% shorter than on Creality machines, so I expect it should require less flushing to prevent color contamination. It is still about 11% longer than the original BambuLab X1 series, but not by much, so I started with 1 time flush in C. In fact, different slicers and printer profiles use different preset flush volumes. A 1-time flush from black to white equals 560 cubic millimeters in the FlashForge skinned Orca slicer, 588 cubic millimeters in Bambu Studio, and 743 cubic millimeters in Creality Print. The estimated print time was nearly 17 hours. The slicer provides estimates for model support and prime tower filament, but like native Orca slicer, it does not estimate purge waste, so we will use a scale to check that after the print finished. I also timed filament changes for this print. The pink to white change took 1 minute 26 seconds, which is in line with previous tests. The pink to white change, similar to other dark to light transitions timed earlier, at 2 minutes 12 seconds. As you can see, the filament only retracts a few inches after printing. This explains why each color changes 10 to 20 seconds faster than other AMS-style systems that must retract the filament back into the box. Near the end of the print, the white filament ran out and the filament runout sensor triggered and paused the print. Fortunately, I had the same white filament on hand, so the print resumed. It finished in 16 hours, 56 minutes, closely matching the estimated time. The Model Plus support used 226 grams, which matched the slicer estimate. The Prime Tower used 19 grams, also close to the estimate. Purge waste measured 217 grams. The slicer did not estimate this, and it just about the filament used to print 4 kitties. The kitties printed very nicely with no color contamination at the default slicer flushing volume. Compared with other machines, although the AD5X used the default flushing volume, the actual purge waste was roughly the same as the Creality K2 Pro, which used 1.3 times flushing. However, the AD5X produced cleaner color transitions. Both the kitty head, black to white, and the neck, yellow to white, looked better than those from the K2 Pro. Ultimately, tool changer machines like the Snapmaker U1 or the Prusa XL remain the best option for multicolor printing, since they print much faster and produce no purge waste. Then I will print the Vegeta model. The forehead on this model usually shows color contamination unless we flush more filament, so this is a good stress test. I will start with a 1.3 times flush. At 1.3 times, the gold to skin purge is just 317 cubic millimeters. This shouldn't be enough, but we'll begin there and see what happens. The slicer estimated about 9.5 hours. I will check actual filament usage after the print finishes. This time, the white to purple change took 1 minute and 26 seconds. Timing the dark to light change again, purple to white took 2 minutes and 18 seconds. Both numbers match our previous prints, which suggests the color change timings are consistent across runs. The print finished in 8 hours and 39 minutes, about 45 minutes faster than the estimate. Model Plus support used 21 grams, which closely matched the estimate. The prime tower used about 20 grams, also spot on. Purge waste measured 131 grams. The slicer did not estimate purge waste. After removing support, most of the model printed well, but the forehead still showed obvious color contamination, even at 1.3 times flush. To address that, I increased only the gold to skin flush volume. On Creality K-series machines, I normally use 1,200 cubic millimeters. This skinned Orca slicer caps the value at 999 cubic millimeters, so I set it to the maximum and tried again. The slicer's time estimate did not change. It still showed 9 hours and 24 minutes. This time, the print finished in 8 hours and 46 minutes, 7 minutes longer than the previous print because of the extra flushing. Visually, the forehead improved slightly, but did not become perfect. Model and support filament remained 21 grams. The prime tower stayed at 20 grams. I expected purge waste to increase by 5 to 10 grams when I raised the gold to skin flush from 317 to 999 cubic millimeters, but the difference was only 1 gram. When compared side by side with the previous print, increasing the flush helped slightly but did not eliminate the forehead contamination. Compared with the Creality K2 Pro, using a 1,200 cubic millimeters flush, the K2 Pro achieved a more acceptable result. The multi-tool head snapmaker U1 requires no flushing and shows no color contamination. These results suggest the slicer should not cap purge volume, or should at least allow a higher limit. Flushing an extra 10 grams would likely produce the same result as the Creality K2 Pro. Next, I will print my own version of the collapsible Master Sword. I have optimized this model over time and removed some unnecessary color changes. My latest version uses about 877 color changes, and the estimated print time is roughly 31 hours. That is much faster than my early version, which had over 1,300 color changes and took about 50 hours. This is still a long print that requires an excessive number of color changes, so it is a good stress test for reliability. I will print the blade separately after printing the body, so the blade does not require any color changes. This run took 31 hours and 22 minutes, which is very close to the 31-hour estimate. The Model Plus support used 108 grams of filament, and the Prime Tower used 41 grams. Both numbers are close to the slicer estimate. Purge waste measured about 575 grams. That sounds like a lot, but compared with my original design, which produced over 1 kilogram of waste, it is a big improvement. The blade printed separately in 2 hours and 36 minutes. That brings the total print time for this set to about 34 hours. The model printed very well, and I have no complaints. The blade slides out smoothly, so this is a perfect print. I will now run my benchmark prints. I also have the 5M, the single color version of the 5X. This simple Core XY retails for around $250 to $299, depending on when you buy it, so it's basically the price of a bed slinger. Both machines and their specs look similar, but the print heads are completely different. You cannot use the 5X's multi-filament system on the 5M. The 5M's print head is lighter, so it should print faster than the 5X. I will print all benchmark models with the same filaments on both the 5X and the 5M, and see if we find any surprises. Starting with the number slider. The printing time of the 5X is slightly faster than average, but the 5M is about 14% faster than the 5X. In terms of top surface quality, the 5X is better. On the bottom, they both printed very well. Both models have good clearance, and the tiles can move freely. For the Honeycomb box retraction test, both extruders can extrude a tiny amount of filament and move to the next point without stringing. The 5X's printing time is about the average 2.5 hours. The 5M is still faster, but since this model offers little room for acceleration, the difference is only about 9 minutes. They both printed well. At the bottom, some honeycombs were squeezed too low on both machines, but the 5X is slightly cleaner with less stringing. Compared with other good printers, the flow rate seems a little high, as the patterns are slightly smaller than the same model printed by other machines. On the bottom, it's more obvious that the holes printed by the 5M are smaller than those from the other machines. Next, the tolerance test. You may be wondering why the nozzle temperatures are different. I used each printer's factory PLA profile in the slicer because I wanted to print straight out of the box without tuning unless necessary. If I make any changes, I'll let you know. The 5X time is also average. The 5M is about 10% faster. However, the tolerance is below average. On the square side, the 5X can only clear up to 0.1 millimeter, while the 5M did even worse and couldn't clear 0.125 millimeters. On the cylinder side, both can clear up to 0.075 millimeters, while a perfect score on this model should be 0.05 millimeters on both sides. As both printers don't have LiDAR or macro cameras to calibrate pressure advance and flow, I will adjust them manually. In fact, I think the flow is fine. I'll see if adjusting the pressure advance alone improves the results. Based on previous results, for the 5X, since the clearance is 2 steps away from the 0.05 millimeter ideal, I will increase the pressure advance by 0.0025 to 0.035 and keep the flow at 0.98 because the cylinder side is almost perfect. For the 5M, it's off even more, 3 to 4 steps away from the perfect 0.05 millimeter clearance, and the profile's pressure advance was set to 0.025, which is lower than any machine I've tested. That explains why it didn't clear 0.125 millimeters. I will increase it by 0.0075 to 0.0325. Based on my tolerance test, these numbers should be fine, or at least bring them closer to 0.05 millimeters clearance. Adjusting the pressure advance won't change the print speed at all, so the printing time will be basically the same. This time, on the square side, both clear up to the tightest 0.05 millimeters. The 5X is still a bit tight and can't clear all the way through, but it's close to perfect. On the cylinder side, both clear up to 0.05 millimeters. The 5X is slightly tight. If I want a perfect result, I can set the pressure advance between 0.035 and 0.0375. Then I printed the Robo Alpaka for the surface quality test, as the 5X's default PLA profile uses a nozzle temperature 10 degrees lower than the 5M's. The surface printed by the 5X with this silk PLA is not as shiny as the 5M's. When zoomed in, the 5X shows much better surface quality, even though it's nearly 30 minutes slower than the 5M. Let's also compare the results with other printers. Compared with the BambuLab P1P, the time is basically the same, but the P1P surface is slightly better, especially regarding ghosting of the text. Compared with the Prusa Core 1, the 5X is faster, but the surface on the Core 1 is slightly better. I can't see ringing in the same areas. Compared with the Creality K2 Pro, the K2 Pro is slightly faster and marginally better in surface quality. Specifically, it shows less ringing than the 5X. Compared with the Snapmaker U1, the Snapmaker is faster and also has better surface quality. I think the 5X's surface quality is decent, though it may not match some higher-end, more expensive Core XY machines. Priced under $400, it still outperforms the Creality High in both print speed and surface quality. Compared with the Sovol SV06 Ace, speeds are similar, but as a Core XY, the AD5X still has an edge in surface quality over most bed slingers. Next, I printed a PLA sheet for the first layer test. Since the first layer prints at 60 millimeters per second, there is no difference in print speed. Both PLA sheets can be peeled off in one piece. The 5X's first layer is squeezed a bit too low, still acceptable, but you can see wrinkles in several areas. The 5M's first layer is perfect. On the bottom, the wrinkles on the 5X are not that obvious. The 5M still looks perfect. I then tried other materials, starting with PETG. The average printing time for this pen holder is about 3 hours, so the 5X is a little faster than average, and the 5M is still 9% faster than the 5X. There's not much difference in surface quality, they are basically identical. Again, the 5X's first layer was squeezed a bit low, while the 5M's was perfect. For TPU, I printed a tire using Eryone 95A on both machines. The maximum flow rate for TPU was set to 3.6 mm³ per second in both slicer profiles, so their max speeds were capped at 45 mm per second. Both prints look decent with good surface quality. Internally, there is minimal stringing, which is still manageable. Finally, I will print an LED light mount in PA6CF. The AD5X product page did not list nylon carbon fiber as a compatible material, but I confirmed with FlashForge that the supplied nozzle is wear resistant and the maximum temperature reaches 300 degrees Celsius, so I see no reason it cannot print nylon CF. The only limitation is the filament selection screen, which does not include PACF, but the filament selected in your slicer have to match the filament type on the printer. So when I load the PACF filament, I selected it as ABS. In the slicer, I created a filament profile based on ABS, but set the nozzle to 280 degrees Celsius and the bed to 90 degrees Celsius, so when I send the print to the printer, it will just print it as ABS with a higher nozzle temperature. The 5M can reach a maximum of 280 degrees Celsius with a hardened steel nozzle, so both machines should be able to print nylon carbon fiber. The 5M is still 3 minutes faster. The print quality is decent on both machines. The only noticeable difference is the 5X did a slightly better job on screw hole overhangs. Otherwise, both models function as intended to replace my broken PETG LED light mount. By the way, this is my second testing bench. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. It combines the BambuLab P1P Core XY platform with the simplicity of the AMS Lite from the A1, integrating them into a compact machine that uses a 4.3-inch color touchscreen instead of the P1P's small LCD. This all-in-one setup works well right out of the box. In terms of speed, it is not one of the ultra-high-speed machines such as the FL Sun Delta series or the Creality K2+, but print quality is decent, and my benchmark tests show it is slightly faster than average. 2. When printing multiple colors, the filament change time is slightly faster than other AMS-style filament boxes. Since it only retracts the filament a few inches above the print head, it takes less time to retract and to feed the next color. It is not a huge difference, on average about 10 to 20 seconds faster per color change, but if your print requires hundreds or more than 1,000 color changes, that adds up to a difference of several hours. 3. The multiple filament system is reliable. I was able to print the Master Sword with 877 color changes without any manual intervention. In terms of reliability, it's on par with the BambuLab AMS and the Creality CFS on the K2 series, making it one of the few dependable multi-filament systems on the market and also the cheapest. It handles different materials well, and we'll talk more about that later. 4. In terms of hardware, the AD5X is solid and well built, with build quality not far from BambuLab's. Setup is simple, and the printer produces good results straight out of the box. You can put everything together in about 10 minutes, so I would call it budget-friendly and suitable for beginners. In terms of hardware, aside from the enclosure and camera, which are not included and must be purchased separately, I can't complain much at this price point. The printer works well and performs even better than I expected. Most of the drawbacks are software related. So now for the cons. 1. The screen UI works, but the layout and formatting can be improved. Dialogues are overcrowded with text and button placement is inconsistent with normal UI conventions. The filament selection on the touchscreen is limited. Even though the machine ships with a wear-resistant nozzle with a 300 degrees Celsius maximum temperature, nylon carbon fiber, polycarbonate, and other engineering filaments are not available on the selection screen. To print nylon CF, you must choose ABS or another filament type that appears on the screen, then manually override temperatures and settings in the slicer. This limitation also affects the 5M FlashForge recommends the 0.6mm nozzles for carbon fiber filaments, yet I have used a 0.4mm wear-resistant nozzle on a Prusa Mark IV and many other machines to print PACF, PCCF, and ABS-CF, with no issues for years, so I don't understand why users must work around to print materials that the machine is supposed to handle. 2. The printer has a profile in the native Orca slicer, but it cannot enable the multiple filament system. You can upload a multicolor job and then start it from the printer, but you lose the convenience of full slicer to printer control. It also does not provide a browser-based web UI like Mainsail or Fluid. FlashForge's custom network UI works with their skin slicer, but it sometimes fails to refresh the printer status after the printer has been idle for a while. When this happens, you can't send prints. I discovered that pressing the Add Printer button forces a refresh. It still works, but it's a bit sloppy. 3. The skinned Orca Slicer caps purge volume at 999 cubic millimeters, which is too low for some prints, such as the Vegeta model. As I'm already generating over 130 grams of purge waste on a model, I wouldn't mind wasting extra 10 to 20 grams to achieve a perfect color transition. Moreover, I'm really not sure if the 999 cubic millimeters flush setting is accurate, because I expected it to flush more filament than the 317 cubic millimeter setting, not just 1 gram more, and to look much better. Overall, the skin slicer does not improve the printer's workflow or offer any advantages over the standard Orca slicer paired with a Mainsail or Fluid Web UI. Requiring users to install a slightly modified Orca slicer is not advisable, especially for people with multiple printers or for business users who must spend extra time updating and maintaining the additional slicer on every computer in their office or workshop. In conclusion, this machine offers exceptional value. It works well right out of the box, the print quality is decent, the speed is slightly faster than average, and it handles a wide range of filaments with some workaround, and the multiple filament printing is also reliable. There are some minor drawbacks in the screen UI and in the skinned Orca slicer though. At this price point, the value is still hard to beat. Compared to 3 years ago when BambuLab first launched and just the AMS cost $350, a single AMS today still costs over $300. In contrast, the FlashForge AD5X with a multiple filament system is a lot more accessible at under $400. Even if you don't print multiple colors, the filament backup mode is a handy feature. For example, if one spool runs out, the printer can automatically switch to a second spool of the same color to continue the print. Alternatively, you can load different filaments so you don't have to walk to the printer and manually change them every time you want to print a different color or filament type. My suggestion to FlashForge is to update the Orca Slicer profile and add a standard web UI as soon as possible. Creating a skin slicer and a cloud printing service is unlikely to provide any real advantage. Most users view that as a drawback. But seriously, I hope FlashForge has no plans to launch another 3D model downloading site, because that would be a full package of unnecessary features as many other brands have already done. That said, based on price, value, and performance, the AD5X definitely deserves a spot on my recommendation list, which currently includes 16 printers out of almost 200 machines that we have tested. Its ranking would be even higher with a fully functional Orca Slicer profile and a refined screen UI. I've added the links to the AD5X and the 5M in the video description. Both offer a great value. Don't forget to also check out AuroraTechChannel.com, which tracks prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.